All right, in this video, we have a polynomial function, f of x equals negative x to the 6th minus 6x to the 5 plus 36x to the 4 plus 216 x to the 3rd. Sorry if you hear a lot of honking outside. And our directions are graph. Now, similar to a little explanation or hint I gave in the last example, if the directions weren't there and it just said f of x or y equals blah, 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 blah. Well, you know the directions aren't going to be to just factor, because if they were to just factor, chances are it would be an expression like this and not an equation. The fact that you have an equal sign means you might be solving something, and factoring is usually involved. If it were equal to 0, it would probably just be solving, which is very similar to finding your zeros or your x-intercept. When it's not 0 or a more polynomial on the other side, however, when it's a y or f of x involved, you're probably going to be graphing. You have two variables. You have an x and a y, technically. You have an input and an output. So when you have those two variables, you're probably going to take the equation and represent it in 2 dimensions, which means on a plane with a graph. So sometimes the directions are confusing to you. You have a lot of words and details. You're like, what the heck do they want me to do? That's just a good way of figuring out what you should do when you have no idea. Okay? So we definitely want to graph this. I had that funny little expression. I don't know if any of you remember the expression that I had, that little statement on a poster in the classroom. If you remember it, amazing. You could type it in the chat, show me you remember it, or if you just remember the letters in order, or if you remember what each letter stands for, anything that you remember from it, if you could just throw that in the chat so I could kind of see who remembers something, anything, even if you get the expression wrong. I'm about to go over it. That was going over the steps for graphing a polynomial function. So, a couple people. And then it's Mallow, Ben, just so you know, M-A-L-L-O. Someone, TR, same thing. But a couple of us remember bits and pieces, so good. So F is the first word, right? And that stands for, so this is where, if you guys know what each letter stood for, you can kind of throw that in the chat as well, like I said, even if someone else already said it. So factor first, right? So we want to get everything factored first. And remember, there's layers to these problems. The higher level math you get, or the further and deeper into any course you get or any topic, the more intricately detailed problems become, examples become, tasks become. So not only, are we graphing and not only are we factoring, well, we also have to remember the factoring techniques. Which one do you try first? This is all from lessons 7, 8, 9, 10, and 11, right? So which factoring method should you try first? And then after we try that one, which one, based on what it looks like, remember we use our eyes to assess the situation first and foremost, and which one do you think you would use after that first one that we always try to wrap it up a little bit further? Looks good. So I see GCF over here, so we're going to try for a greatest common factor. If you ride the struggle bus with finding the greatest common factor, you feel like you never take out the biggest thing, remember, prime factorization and factor trees will be your absolute best friend. Now, what I'm seeing is a lot of people putting x to the 3rd. I see 2 people that put negative x to the 3rd. Amazing. You cannot forget that. Will you get the wrong answer if you don't take out the negative? No. But will your life be 1,000 times easier if you do take out that negative? Yes. I cannot stress that enough. It is so helpful because it'll reverse the signs. If any of you did not take out the negative, you're going to see what I mean, why what I'm doing is easier. It's going to kind of reverse the signs on things that you should, with your eyes, easily recognize as something to quickly factor. And it messes with your head. Like, you don't understand what you're looking at. You don't see the factoring you can do. And the rule I always give with the GCF is if the leading term is positive, you take out a positive. If it's negative, take out the negative. So negative x to the 3rd will be what I'm really dividing out. And that means I'm multiplying a negative x to the 3rd out front. That makes it a 1. That keeps it balanced. Then we reduce. This is how we, lesson 4 or 5, how we divide polynomials by monomials. So we're going to divide, right? If you know what we get inside, amazing. If you remember how to make an exponent with your keyboard. If you used an Apple computer, it was Control, Command, and Space Bar. You type the number, and it should come up as a little exponent on the side. You can use that. But the way you guys are typing it with the caret is perfectly fine. So if you want to tell me any of the 4 terms that would go inside, you could type that into the chat as we go across. So I know the first one is definitely x to the 3rd. And all my signs are going to become the opposite sign. So I know I'm going to have a plus sign, then I'll have a minus sign, and then I'll have another minus sign. Just peeking up to see what people are writing. I do see 6x squared was there. Good. I also see a 36x. I see minus 36x. So there's that minus, and yes, 36x. And then last but not least, if we took out the negative and the x cubed, I'm only left with, 216. And we should recognize 216. 216 shouldn't be like a stranger to us. You should remember that number. Maybe you remember why you remember it. What is equal to 216? Where did it come from? Anybody remember why we've dealt with 216 in the past? What is 216? Yeah, good, Faye. 6 raised to the 3rd power. When we were going over our cubes, that was on our list. And that was one that was kind of a struggle for everyone to remember because it's a little unfamiliar. So we're going to do grouping, like I think it was maybe Karen that said to do grouping. So I'm going to do that from here. That is my first group and that is my second group. See that minus? It's the same concept as there. So you could tell me GCF for each of these. You could tell me what's going to be left inside. Whatever bits and pieces you can throw in the chat. If you feel like you're getting a little far ahead, maybe you write down whatever you're typing with a little sentence or statement so people know what you're talking about. I don't know why I just drew that line there. Sorry. Okay, so I see people are telling me that the GCF for that part is x squared, and I see people wrote negative 36. That's good. So I'm going to write my x squared. We'll figure out what's left. I'm going to write my minus 36 here, see what's left, and then close that out. Then left inside, we again are dividing a polynomial by a monomial. Back to lesson 4. That's what we did. So we need to just figure out what's left inside over there. And if it matches, we are happy. So x plus 6, I see a few of you wrote it. X plus 6. Sorry, my 6s start looking like B's. Let me round that out a bit. Okay. Next line, keeping that f of x. You don't want to drop parts of your equation. A lot of you guys do have a little messy math habits with that. So you just want to be careful because it does kind of mess some people up. Always also read to yourself what you're writing and keep things kind of neatly organized so you don't lose any terms anywhere, okay? Are you done factoring? Can you factor further? What factoring method can we use if we can? How would it factor? What vocab words associate with what we're doing? And then after that, could we rewrite things any which way? So seeing a bunch of words coming up. Good and good. Yes and yes. What's the word to describe those two factors, how they relate to each other? Everyone's favorite word. So I'm rewriting that. I'm leaving that. You guys told me this is the difference of two squares. Nice. And you wrote x plus 6, x minus 6. Those are called conjugates of each other. Can I, before I carry on, some of you didn't catch it, but when you were graphing, you were like, wait, what? Can I rewrite this a little better so when I graph it, I don't run into any headache? Yeah, Suki, good. So some of you didn't catch that. You had the same factor twice. And I'm just going to be a little excessive about this one over here. You know, you don't have to write it like that. But the x plus 6, since it's twice, it's squared. That tells you something about the behavior at the 0 that corresponds to that factor. Because some of you, when you were graphing, what accidentally happened, you were like, wait, how can I be linear and then linear again at the same place? Like, you were so confused how you had the same factor 2 times. Well, think about it. If you're linear and going through and then linear again going through, that's when you walked over the bridge and you were like, wait, I want to go back. And you walked over the bridge again. That's what creates that quadratic behavior. So let that be a trigger in your brain to remind you. So we are fully factored. Factored first. Fully factor first. F words for days. Next word started with the letter Z. What does that stand for? And then tell me all about it. So zeros, those are also that's a nickname for your what? How do we get them? What do we do from here? Type something in the chat for me. Good. So they're the zeros, x-intercepts, and we get them by setting the inside, so don't worry about the cube, inside or the square of each parenthesis or factor, yes, good, equal to 0. So x plus 6 is equal to 0, x minus 6 is equal to 0, so x is negative 6 and x is 6. So if you got the three numbers that I got for your zeros, let me know in the chat, type a smiley face or something. If you got the same three x-intercepts, same 3 zeros, type me a little smiley face in the chat. We got our zeros, at least you had that. Okay, smiley face, yes, that's all good. All right, so that's a good start. E is the next word. What did the E stand for? And I have two E words that I like to mention whenever we talk about that. E and behavior. Good. Not only on behavior, but I like to remember it's easy. Well, three E words. Easiest to find the end behavior from expanded form. It's easiest to find the end behavior from expanded form. So I look over here at the expanded form. I have negative x to the 6th. So what is our end behavior going to be with negative x to the 6th power? Nice. Down and down. So that's going to help us. P. What did this P stand for? I kind of said 4 P words, but there's one main one. Plot, right? Plot points. Put it on the paper. Plot points. Put it on the paper. So I'm going to go over here, draw myself a little graph. Don't label any tick marks on your y-axis. We don't know how high and low everything goes. You guys saw that when we were on Desmos. Like things were stretching and compressing all ways of crazy. Those curves go so high sometimes. So like for you to put tick marks on here, don't even bother right now. In calculus, we definitely do that. In pre-calculus, we're going to play with it a little bit here, but just leave your y-axis blank, okay? So I'm going to go over here. 1, 2, 3, 4, 5, 6. To be honest, you don't even really need to put all the tick marks. Just kind of space things out. Say this dot is 6, this dot is negative 6. Save your time, you know? Here is the 0, and then 1, 2, 3, 4, 5, and negative 6. Down and down, I just put itty bitty arrows. You might not pass through them when you get it all drawn, but you want them there to know where to start and finish your graph, and this way you know if you mess up sooner than later. So plot points, put it on the paper. We did that. M was the next. What did M stand for? Okay, I see the word multiplicity. We're going to mark up our multiplicity. So the multiplicity we find by looking at our factors exponent. I'm going to put a 1 here so it doesn't look like a 0. 1, 2, and 3 are the three multiplicities we're going to really deal with. 2, 4, 6, 8, blah, 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 are all the same. 3, 5, 7, 9, blah, 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 are basically all the same. They're a little different, but they look visually similar enough that we don't worry about, editing from there. Okay, so how do I mark up my multiplicity? Well, 0 was a 3, so I'm going to put a little C near my 0, so I remember it's going to behave like a cubic. 2 goes with this one. See, everything's above. Some of you guys are still stacking your equations, and then your work is all over. Keep everything underneath the factor, okay? It's going to help you out in the long run. So it's going to behave like a quadratic at negative 6. Careful. Some people were labeling this. These two things happen. Ready? People just go in order from left to right. They write cubic, quadratic, linear because they think the factors are aligned with their intercepts. Anyone guilty of that one? That you accidentally mislabel the behavior on your picture? Or when they have positive and negative of the same, you see the plus 6 and you put that behavior on 6. And then you see the minus 6, you put that behavior on the negative 6. So that's another one. Anyone guilty of that one? Where you accidentally mislabeled and things looked funky? So, all right. Thank you for being honest. You guys get a high five, gold star. So here is the -6 and the 6. Okay, so the -6 came from that. That one I put a little Q near it for quadratic. And then that one is the +6. I'm going to put a little L so it's linear. The other reason I like to mark them is for you guys especially is I know you make those cubic curves kind of wonky. It's okay. But if I see the C, then I know, you tried. What you wanted it to look like was that shape, and it might look a little doofy. That's fine. So quadratic with this side pointing down, you want to take from the dot, treat it like the vertex. You're going to scoop down as best you can. You don't want to go too crazy because you don't want to get too far down and deal with that. So I'm just going to go a little bit down, scooping down over here. All right. Do not cross your x-axis anywhere else. If you have to take like another piece of paper or something and tell yourself, I cannot go through here, because some of you will, some of you did, right? I walked over to your desk and I'm like, you told me you have 3 x-intercepts, but you crossed through your x-axis 4 times. And you're like, what? Oh, wait, what? Wait, but wait. And you get confused. I know. Cubic. I know I'm already on the bottom, so half of it's down here. I know this is the one that looks a little ugly when you draw it. I'll connect them in a second, and then this side is scooping the other way up. So now I'm going to figure out some curvy piece to connect them. It kind of reminds me of those, like, I used to love this when I was a kid, like, I don't know, but you guys probably had cooler toys, but it was like those little railroad kind of tracks. They were like plastic, and you would clip them to, you know what I'm talking about? Clip them together, and you make a little thing for like cars to ride on. It wasn't like a electric race car thing. It was very, very basic plastic little tracks, and you had like curved pieces, and you had straight pieces, and you put the tracks together, but you can't always put them together a sharp turn or something like that with a curved one. It wouldn't fit, right? And it would mess up the curve. So I feel like, I want to curve it and connect it with those little railroad tracks and make it look nice and normal. All right, and then this is linear, we're above, so we're going to kind of go down pretty straight and finish down, so that's good. And we just nicely try to figure out what curve piece would go in here to fix this, kind of like you are a roller coaster designer and you have to make a nice, safe roller coaster right there. And actually, it also reminds me, I was just at someone's house who has a train underneath their Christmas tree, and they put the track pieces together, and they didn't use all of the pieces they needed for the circle, and the train kept falling off the track every time they turned it on, because your curve that you have needs to make sense with the wheel spacing on the train. Otherwise, it's going to mess up, fall down. You have to fit it. So I kind of think about these things when you draw this. Did anyone draw what they think was the perfect graph on their quiz the other day? Any of you guys think you got it right? And if you are saying, a couple of people are saying no, do you think you know where you messed up? And if you do, you want to let me know where you think you messed up, what you missed, or what you miswrote. If you think you have an idea of what your mistake was, I have your papers in my bag across the other side of my apartment. I don't feel like going to get them, but if you think you remember, sometimes when you go over it, hindsight is 2020. Like, do you think, I factored it correctly or got the right zeros, but so when you didn't put it as squared, you kind of got a little tripped up. So did you make it linear and then you were confused why your end behavior wasn't correct? Or did you just get sort of stumped at that spot and you were like, I know it's supposed to be down, I know this is supposed to happen, and you made up something else somewhere? How did you recover? Do you know? I'm guessing, Eli, Elena, you don't know what you tried to do to recover from that. Well, that's the end of this example. I'm going to record the other 5th example with one of the other classes this afternoon, and I will do what I've been doing. I'm going to share that video. Additionally, I will share videos and a list of what the topics we're going to cover next are. I'm going to share a playlist with you guys that you'll have access to over the break. If your family, wants you to help with chores and take down the lights in a tree and put things in the attic, and you're like, really don't want to do that. You could be like, my math teacher posted videos and I really want to take notes and be a good student. Sorry, can't help, and have an excuse. Then you could watch the videos. By all means, you don't have to watch and take notes, but if you're the type of person who would like to take your time, take nice notes, put them in your notebook, and then when we're in class in January, you could kind of rest easy, pay attention, get to listen and take it all in and maybe participate more, amazing. If not, you don't have to. I'm not forcing you. I'm not going to twist your arm, but I will share, because I have a bunch of things already recorded. So I'll share kind of lessons and examples for you to add to your notebook if you're the type of person that wants to use this time to do that.